my screen is in presentation mode, correct? Piero, I'll just let you can tell me when it looks like the waiting room is slowing down and we can go ahead and start.
I think you can begin with the housekeeping notes.
Perfect.
While people join.
Sure.
There's no one in the waiting room at the moment, and I think you can start.
Okay. All right. Well, welcome everybody. My name is Lena Cordy-Bancroft. I'm one of the leaders for the UK RAPS UK local networking group. Not yet a chapter, but we are going to work our way to that level. Today's event is Achieving Sustainability in Healthcare. So if that's what you signed up for, awesome. If it's not, you're also welcome. So please don't drop off. The more the merrier. Just a little bit of housekeeping. This event is being recorded, so it'll be made available afterwards, so you can view it at your leisure. Just a couple things. You can put your questions into the Zoom chat box. This isn't set up like the Zoom webinar, so there's no Q&A box. So just use the chat, and we'll have questions at the end after the 3 different presentations are complete. And then the presentations will be shared with everyone after the event when we send out the link to the video. If you want to, or when we get to the Q&A, please feel free, if you can just, like I said earlier, put the questions in the chat, or if you feel free, raise your hand and we'll unmute you, and you can ask your question live and in person, well, live and virtually to our presenters today. So just a little bit about, we always start our just some stuff regarding RAPS. Remember the Euro Convergence registration is still going on. Early registration ends a week from, there we go, ends a week from today. So it takes place May 10th through 12th in Amsterdam. It's going to be an awesome in-person event. Was there, I can't remember, 2 years ago, I think was the last time we had the in-person, and it was a lot of fun to be there. Awesome venue, and just great to be in person again. And there are the pre-conference workshops as well if you're interested in attending those. So lots of different tracks, and this again it's similar to how we do Convergence in the US, but this is really focused on events in Europe. Upcoming events for our local networking group. We've got our next one coming up in May, end of May. We had to do some jiggering around thanks to the UK government shutting down for PERDA. So we're not able to really talk about the draft UK regulations, because we probably won't see anything now until after the summer. So that's been moved, and then we took out July and August because didn't think anybody would really be attending when they're enjoying the wonderful British summer. So in May we have the UKCA UKNI marking, and then in June we'll have a UK responsible person and device registration update, and then join us back in September again. I forgot one thing regarding Convergence, the Europe Convergence. The UK chapter will have a table there for to stop by and get information from us and say hi and meet all the everybody else who's there from the local networking group and UK area as well. This is just some information for contact. You can contact myself or Rena Neer. We also have Richard Vincent and Giovanni De Rienzo on the planning committee. So reach out to any of us. Social networking, we're on regulatory exchange on the RAPS page, but we've also just created a LinkedIn page in addition to our group. So we'll be able to get more information out to you in a much more I think in a much speedier way, and it'll be more accessible to people from the LinkedIn page. So with all that underway, we're going to move on to today's event. It's Achieving Sustainability in Healthcare. It's a huge topic globally and among all sectors, and very important in healthcare, but it seems like people just kind of sit there with the deer in the headlights look when we talk about, well, what are you doing regarding sustainability? And what are we doing? And what do you mean sustainability? So we've got some excellent speakers here to kind of get you start thinking about that, and some different considerations and ways to look at your medical devices in the various life cycles of the product. So we've got Matt Morris from Cambridge Design Partnership, who's going to talk about a little bit the design and manufacturing aspects of products and sustainability. We've got Jenn Goff from Oliver Healthcare Packaging, and Kiley, I can never say your last name, Djupstrom from Plastic Ingenuity. They are representing, they are the co-chairs for the Kilmer Innovation in Packaging group, and they've got a lot of interesting stuff that the group is doing on sustainability. So looking forward to making you aware of what is being done in industry related to packaging and sustainability. And then we have Anna Lindblad from Olympus. I've had the pleasure of listening to her speak before, and it's really interesting to see what can be done regarding sustainability from a decontamination and disinfection sterilization aspect. So that's the order that we'll be doing this in, so you can kind of see that life cycle approach to sustainability. Just to kind of set the page for everybody, I have some slides from ABHI. So I think their sustainability group presented these, and just kind of where are we and what are we looking at? And you can see that here in the UK, the NHS has really set up a pretty progressive roadmap in terms of what they are expecting. And really the bottom line is that if you are not ready, if you're not looking at sustainability, and if you're not ready to meet some of these marks, deadlines that they've set, the NHS likely will no longer purchase from you. So it's really important that you start getting thinking about what plans you're going to make for sustainability, so that you can hit some of these benchmark dates. And there's lots of information out there. We're not going to necessarily get into what the NHS and UK goals are, but the net zero stuff, but that is definitely something that you'll want to look at. Just an FYI, we do have, BSI also has net zero week next week, and we'll be talking about sustainability with and the net zero initiatives related to NHS. So if you're interested in that, ping me and I can send you registration information. And then again, the social values for the greener NHS, they're looking at these 5 different themes. You've got COVID-19 recovery, tackling the economic inequality, fighting climate change, equal opportunity, and well-being. And really, when it comes to sustainability and the medical device and healthcare, looking at what are we doing to help with that climate change, and really helping make sure that we are doing whatever we can to make our our carbon footprint a lot smaller, and hopefully helping us get to the net zero accomplishments. And then these are just very briefly, you can find these all over the UK NHS websites, but the different strategies and different roadmap plans for the devolved nations. So pretty aggressive, and really the UK is looking to be a leader when it comes to the initiatives for sustainability. So with that, I'm going to pass it over to Matt, so he can kick off with the presentations. And again, feel free to put your questions into the chat box, or you can wait till the end and raise your hand and you can ask them live. All right, Matt, looks like your presentation is showing now.
Yeah, okay, fantastic. Well, hello everybody. My name's Matt Morris. I lead Cambridge Design Partnership sustainability team. Just really quickly, a little bit about me. I'm a mechanical engineer by background, and I actually started my career in sustainability policy, so advising UK government, European Commission on energy and climate change policy. But at Cambridge Design Partnership, I've been leading design and development projects across the consumer and medical sectors. In the medical side of things, I have worked on a variety of medical devices, from drug delivery devices through to robot-assisted surgery. But whilst I'm not a regulatory expert, like many of the people on this call, I've taken medical devices through CE approval, including the CE audit, where the notified body was BSI. So nice little story there. So I work for Cambridge Design Partnership. Really quick introduction to CDP, as we call it. So we're an end-to-end innovation partner. Let me just briefly describe what that means. So we support clients all the way from early insight and strategy right through the design and development process. We've got around just over 300 designers, engineers, scientists in 2 sites, one in Cambridge, UK, and one in Raleigh, North Carolina. And we have, we've got strengths all across technology selection, development, supporting innovation, right through to building supply chains, transfer to manufacture, and regulatory approval. We operate across 3 sectors, consumer, healthcare, and industrial. In healthcare, we work in drug delivery and medical therapy and diagnostics. But I think these 3 sectors all experiencing significant sustainability trends that are impacting all the businesses we serve in those areas, but in very different ways. So looking at the consumer sector, and particularly packaging, hugely exposed to consumer pressure on plastic waste and invested pressure on climate change. And I guess if I was to judge by the level of interest that I'm seeing across consumer and medical clients, consumer in terms of the level of urgency is probably somewhere in the region of 3 to 5 years ahead in terms of the level of investment that's being put in. And that, I think, is just a factor of the level of exposure that those businesses are experiencing. But there's another couple of things that are interesting about the consumer sector. One is that the cost and time to market's a lot lower, meaning that you get more design iteration cycles, and it also allows for more startups to be involved because the cost to enter the market is a bit lower. And what this means for companies in the medical space is there's this kind of test bed of approaches to sustainability that have potential for transfer, obviously with some caveats because the 2 are not the same, but there's enough potential there, I think, to have a serious look at what's going in the consumer sector and what could be transferred across. I'm going to focus on high volume plastics and packaging. So in healthcare, that'd be things like drug delivery devices, single-use medical devices, diagnostics tests, that kind of thing, because I think that's where there's quite a lot of potential for transferable lessons. Before I get into that, since I'm first up, I feel like I have to set the scene a little bit. First, I think it's really important to mention that sustainability, that's a really broad term, includes an awful lot of things, including, for example, human health, which everybody in this call is very heavily invested in. But it's important that sectors and companies focus on the aspects that are most material to them, where they can have the biggest impact. I'm going to be talking really about environmental sustainability, and particularly climate change and responsible consumption today. But I think it's important that we don't lose sight of the bigger picture, because often there are trade-offs to be made between one thing and another. And I think that's really important for everybody to recognise. But if we look at climate change, so one question that comes up quite often is, how urgent is it that the healthcare sector addresses their climate impact? You know, it's a very highly regulated sector. Could other sectors that are less constrained shoulder the burden initially? The healthcare sector is exempt from a lot of existing environmental legislation, and actually I've been catching up recently on the Sustainable Products Initiative, which is a directive that's going through the regulatory process in Europe, that will kind of extend the eco-design directive to a lot more products. And it looks like at least pharmaceutical delivery products will be exempt from that directive as well. That said, I think a kind of sit tight and assess approach, we might call it, probably will be short-lived in healthcare. There are three reasons for that. One of them is healthcare is a pretty big part of global emissions. So I'm showing that on this slide. By the way, I hope you like graphs, because I do. 5.5% is a number that's bandied around. It's not really important exactly what the number is. That order of magnitude is the really important thing. That's pretty significant. You know, when I look at this this lovely pie chart, there aren't that many slots of the pie that are bigger than that. And you know, to put it in context, if we look down at the bottom right-hand corner of the slide, you can see global aviation and shipping. Healthcare sector is bigger than global aviation and shipping combined. Another one that sticks out to me is deforestation, 2.2%, so less than half. So it's not insignificant at all, although obviously it's kind of bound up in a lot of these other sectors. The second reason I think that action will need to be taken is we're experiencing a transition of healthcare from the clinical setting to homes. And that's a good thing for quality of life in a lot of ways. People are able to manage their conditions at home. They don't need to go to a clinical setting. Ideally, they don't need to go to hospital. That has a huge number of benefits. But what it does mean is that companies supplying medical devices are getting increased exposure to consumer preferences on sustainability. And that's what's driving a lot of the urgency in the consumer sector, particularly around discarding single-use plastics. And you know, you can look at the reaction to lateral flow tests on social media to see some of the opinions that are being shared there. And the third reason, healthcare companies are setting science-based targets themselves anyway. I think that's largely being driven by investors, and also looking at the way the picture is coming up with the NHS and other large providers starting to say, if you're not sharing our net zero ambitions, then we don't want to buy products from you. So Science-Based Targets Initiative is a set of externally verified targets for greenhouse gas emissions. And the idea is that companies set targets that are in line with keeping global warming below 2 degrees centigrade. And you can see here, so what we've done is we've looked at companies that have signed up across the last 5-6 years. It's an exponential growth curve. And then we've mapped on some of the major medical pharma companies when they signed up, and you can see that's growing really fast as well. And all of those companies, of course, will then need to set requirements on their supply chain pertinent to these targets. So an interesting question is, what level of action does that actually entail? So I've got another graph for that, don't worry. So this one is from the most recent report from the Intergovernmental Panel on Climate Change. I'm sure everybody's read it. It came out a couple of weeks ago. And this is the scenarios they've laid out for decarbonisation. So if you set a science-based target as a company, and maybe some people on this call have, then you're aiming for somewhere between the green and the blue curves. There's actually a little bit of revision potentially happening to that, the Science-Based Target Initiative, but somewhere around there, okay? So if we look at 2030, which is a good benchmark, or a good milestone, let's say, 8 years from now, globally, we're going to have to go down from 55 to 35 gigatons of carbon dioxide equivalent. So that's about a third off in 8 years. And then we've got to keep that momentum up as well. if healthcare doesn't change at all, it becomes around 10% of global emissions in 2030, 15% in 2040. Those are big numbers now, really big numbers. There aren't many sections of the pie that big at all. So clearly, changes will have to happen. And the other thing I'll point out is what's 8 years in healthcare? It's not that many development cycles because it's such a highly regulated market. Things take quite a long time. So, you know, there isn't that much more opportunity to sit tight, I don't think. So hopefully that's established the need for taking action, if you didn't have that already, which I'm sure you did. So what type of action can you take? So I work in design. I'm interested in design, and the way we look at it, there are 3 levels of change that that you can make in a design. I'm going to start from the right-hand side, slightly paradoxically, because that tends to be what companies look at first. So detailed design. So I'll define that as short-term modifications. In medical, I'd say that either don't have an impact on the regulatory submission, or the impact is minor, because that, you know, as soon as you start to get into that, that slows things down significantly. And we're looking here for quick wins. So the nice thing about this area, and the example I've given here, dairy milk buttons. Okay, so if you've been in the supermarket recently, you'll notice that a lot of the packaging is getting smaller and flimsier, and this is the kind of thing I'm talking about. Actually has a surprisingly large impact, but it isn't going to get you where you need to be 2030 and beyond. We move on to product design. So that's a completely new product, but basically working within the same system. The example I've got here is a company called Fairphone, which you may have heard of, that has a modular mobile phone. That company's doing pretty well now. The first Fairphone wasn't that great, but now the company's growing really nicely. And actually, I think what happens, that's a startup, and what happens in the consumer sector is those startups, once they're successful, that change filters down to the major companies. So, for example, we've seen iPhone or Apple releasing repair manuals for iPhones, something that they've resisted doing for the best part of a decade. And then the most ambitious, most exciting, but most challenging type of change, system design. So that's a completely new way of delivering a clinical benefit, let's say. But it gives completely, you know, a step change in sustainability. The example I've given here from the consumer sector is Loop. So Loop, if you're based in the UK, you can go to some Tesco stores and buy some of your grocery shopping in completely reusable packaging, then gets sent back to be reprocessed. So that's a completely new system that had to be set up. It's much more challenging for companies. A lot of businesses are not really that well suited to the type of collaboration across the value chain that's required here. And I think that's one of the key challenges of sustainability going forward. So that's the 3 levels. So, you know, I'd say the consumer sector, especially packaging, a lot of work has gone into detailed design. And you can see that every day when you interact with packaging. Product design, we're seeing a bit of that now hitting the market. A lot of it's from startups. And like I say, that then percolates through to larger companies and scales up that way. System design, even the consumer sector is really still grappling with this, but there are certainly some lessons. So what can we learn, I guess, that's relevant to the healthcare sector? I've got 5 things. You can only have 3, 5, or 7 things, I believe, in consultancy. So I've gone for 5. So here goes. First thing, let's exhaust the quick wins, but let's not get too distracted. So that's the kind of detailed design stuff I mentioned in the last slide. It's often an optimization game. It can often lead to cost benefits. So this graphic here shows a bit of high-level analysis we did of a UK lateral flow test kit that we received. So we took the parts, we weighed them all, and we did a quick life cycle assessment to understand how the environmental footprint of these lateral flow tests, or one test actually, breaks down. And that's what you can see on the left-hand side of this graphic. And then we looked at some quick wins that could reduce the carbon footprint. And most of these, by the way, these quick wins are actually already implemented either in some lateral flow test kits, but not others, or in other lateral flow test kits, not COVID-19 tests. So it's not like they're completely off the wall. And what you can see is you can get a surprising amount of improvement from these types of things. And they're good for two reasons. One, you can often do things like this to products late in the development pipeline or already on the market. And you might have seen actually lateral flow tests in the UK change quite a lot over the course of the pandemic. And some of that was to improve the material efficiency. And the second thing, reducing the amount of material that's in use in a product is really essential in making the circular economy manageable, because at the moment we're dealing with way too much volume, and the investments needed in recycling or reuse infrastructure are staggering, and everything we can do to reduce the volume of material that's going onto the market is making that problem more manageable. So that's a really important thing about this type of optimization. And my sense is that whilst some parts of the healthcare system have looked at this in some detail, others haven't. And there's a pretty ready process for it, using life cycle assessment and then looking at areas for optimization. And I think you can expect to achieve maybe somewhere 5 to 20% improvement, depending on your product in this way. Why do I say don't get too distracted? Well, because 5 to 15% isn't enough for 2030 and beyond. And some of these other initiatives take a long time to get going. So we need to do both in parallel. That's my view. Number two, recycling is about systems, not just product design. That's a shame because I'm a product designer, but I think it's true. So this graphic shows all the conditions needed for a successful recycling system in the US and Europe. And what I've done is I've put a red ring around everything that's directly influenced by the design. And what you can see is it's less than half of the things. And actually the big barrier to recycling in the consumer sector is economics, and particularly getting high quality, pure source of recyclate in a cost efficient manner. That's the real challenge at the moment. And to resolve this, it's not good enough to just design a technically recyclable product and hope for the best. That's not going to get us where we need to be. Companies need to get involved in the full value chain to resolve this. And we're starting to see that happening now in the consumer sector. And an example I'll give is a European project called Project Holy Grail. So that is a huge consortium of companies all across the packaging value chain, from brands, retailers, all the way through to manufacturers, and then also recycling system operators, suppliers of recycling system machinery, all of these companies working together to work on a system to much more effectively and efficiently sort recycling at the material recovery facility to get high quality output, which is a really big barrier at the moment. And those sorts of initiatives are springing up all over the place. We have some of those in healthcare, but I think we need a lot more. And I think all the companies that are placing consumable healthcare products on the market need to be thinking, where are we involved across the value chain to try and resolve some of these problems? One of the big things, by the way, that has been learned is you have to have a source of demand for the recycled products to get the economics to work. So that's why you'll see huge targets for recycled content from consumer companies, like, for example, Coca-Cola. There isn't actually enough recycled PET at the moment available to supply these companies, but they know they need to create a source of demand to trigger the investment. And you might be thinking, well, that's all very well, but it's not possible to use post-consumer recycled material in medical products. And to a certain extent, I would agree, but I think perhaps we need to look carefully where those opportunities might be. And just to give you a couple of examples from the consumer sector that might transfer over, there's obviously now an FDA-approved process for recycled PET in food trays and beverage bottles. Obviously a lower regulatory burden than many medical devices. But it's interesting to think how that could extend. And then another example I'll give, so beauty cosmetics tubes like this, you can get tubes like this now that are laminated with multiple grades of polyethylene. And that means that the material in contact with the drug, well, not the drug formulation, sorry, the product formulation is virgin, but some of the rest of the material that really just provides structure and actually isn't in contact with anything sensitive is recycled. And so that kind of multi-material, well, actually single material, but multi-source lamination, I think is an opportunity in some of the lower risk areas in healthcare. Okay, the third thing, electronics is a bit of a problem. You can't really recycle electronics. And I think electronics in healthcare devices is a big trend. This is a graph from a recent issue of On Drug Delivery that was produced by Philips Medisize. And what you can see, the stripy bars are basically the additional impact from adding electronics to an auto injector. And I'm looking at greenhouse effect because that's what we're mainly talking about today. Adds about 50 to 100%. That's a lot. And particularly in the context of companies that have got science-based targets to reduce their impact. As another example, an iPhone 12 weighs 164 grams. I did have to look that up. Has a carbon footprint of around 60 kilograms, which is the same as around 20 kilograms of steel or polypropylene, or 1,000 lateral flow tests. So electronics has a big carbon footprint, and the reason for that is the materials need to be exceptionally pure, and they're very exotic materials in very low quantities, and that's not a great recipe for recycling. You know, given what I just talked about the need to get pure, high concentration streams to make the economics work. So in the short term, at least, reuse and remanufacture are the only game in town for electronics. And I think from the consumer electronics sector, we can expect methods for designing components, connectors, and modular designs that will transfer across. And I think that's something that the medical industry can look at, because the volumes in consumer electronics are so much higher. Number 4. Electrification is a mature decarbonisation technology. Don't try and look too closely at these graphs. I'll explain them. I do love a graph. So this is again from the IPCC report. What it's basically showing is just how much the cost of renewable electricity has fallen. So much. And the grey bars, if you can see them, are the cost of fossil fuel generation. So we're now at the point where renewable electricity is at cost parity, and in some cases cheaper than fossil fuel-based generation. How does that relate to healthcare? Clearly, it makes sense to electrify manufacturing processes and other processes where possible, but everybody's doing that already. The thing that I think is interesting is it also means that in the medium to long term, shifting the design from materials or processes that are hard to electrify to those that are easier to electrify is a good strategy for decarbonisation. I think that's another plus for reuse, because operations like cleaning and sterilisation, recycling, they're amenable to electrification. Making new molecules from raw materials is a lot further away, in my view, from that. And finally, lesson 5. In a circular economy, unique is not always good. So I've got 2 examples here. The first is Colgate. So Colgate did quite a lot of R&D effort, invested a lot of effort in designing a fully recyclable toothpaste tube. So again, monomaterial, high density polyethylene. That doesn't mean any toothpaste tubes are going to get recycled, because they don't control enough of the market to allow that to happen. Nobody's going to sort out the recyclable from the non-recyclable toothpaste tubes. So what they've done, they have placed the design and access to the manufacturer open source, and they've encouraged other companies to come and use that design. I think that would have been unthinkable not that long ago. So this is a company that's invested R&D in a process and then has allowed their competitors access to it. And that's because it's painful to be the first in a circular economy. The other example I've got here is to the right, a company called Club Zero that operates reusable coffee cups in North London. Something interesting they said, so you can see the design there of their cups, kind of boring. And that's deliberate, because they found that if the design's too exciting, they don't get the cups back. And that's another example where we're seeing standardization of designs in order to achieve economies of scale in the circular economy. So my question, I guess, is what does that look like in the healthcare sector? Where novel delivery devices are a huge source of R&D investment. How is that going to pan out in the next 5 to 10 years? So those are my 5 lessons. Thank you very much. I'm gonna end just with one point. A lot of those sustainability strategies pose significant regulatory and risk challenges. Implementing quick wins that don't impact the regulatory submission involves looking really carefully at what can be done without significant regulatory changes. Incorporating recycled content involves looking really carefully at the risk profile of doing that. Reuse involves a completely new assessment of risk. Without these things, it's going to be really difficult to mitigate the environmental impact of high volume medical plastics at the scale and speed that is needed, and that companies have committed to through their science-based targets. So I think risk and regulatory professionals are key to decarbonising the healthcare sector. And that's what I'd like to end on. Thank you very much.
Excellent. Thank you very much, Matt. There is one question that I'm going to just ask you now, because it's really relevant to your presentation, and a lot of the other presentations are a little bit different and may not flow well later. So Cormac is saying the point about reducing material volume is interesting, but isn't this only relevant if you're throwing that material away? Is there an argument for making products and packaging more sustainable if a way can be found to reuse it? That might go into a little bit about that second to last slide where you're talking about Colgate and Club Zero.
Yeah, okay, so I think Cormac, let me know if I've got this right. So what you're saying is we're talking about optimizing by reducing material, but then that kind of runs counter to reuse, where if you're reusing the material, do you really need to reduce it down?
That's exactly the point, yes.
Yeah, and I totally agree. And you need to have a predetermined strategy, I think. And actually we're seeing that slightly in the consumer sector, where you could package something in flexible packaging. Flexible packaging is actually really hard to recycle because by its very nature it's so light. And reusable flexible packaging is at the moment a non-starter. So I think it's important to have a clear strategy about what you plan the life cycle of your product to be, and then design for that. Completely agree.
Thank you.
Excellent. There are some other good comments in the chat as well. Dr. Helen Meese has a really good point about there's a need to address how companies drive sustainability across their supply chain. And that's absolutely a huge thing, especially as if you want to sell into health systems like the NHS, what are you doing to make sure that all the way down you can't carry the burden yourself. You spread it out and really use your supply chain partners with that. So thank you very much, Matt. It was very informative. The numbers kind of go over my head and I always have to sit back and relook at them. But if you have any follow-up questions for Matt, please continue to put them in the chat and we'll bring them up again at the end of the session. So with that, I'm going to move on to the tag team duo of Kiley and Jenn. I'm not sure how, do you guys, one of you going to use the slides and just go ahead and share your screen and however you are ready to present that. So Kiley and Jenn, it's all yours.
Excellent. I will get started here. All right. Can you all see my screen? Okay, great.
Yes, we can.
So Matt, you did such an excellent job that there are probably a few slides here that I'm going to breeze through because you've already kind of given us the case for sustainability. You did an excellent job. So excellent presentation. So I am Jenn Goff. I'm our Global Director of Product Strategy with Oliver Healthcare Packaging. And I am co-presenting with Kiley Djupstrom, who is the commercial leader for Plastic Ingenuity. You want to say hi, Kiley?
Hello.
Hello. Great. So I'm a packaging engineer. I've been a packaging engineer for 17 years, all in healthcare. I've worked for Stryker, Edwards Life Sciences, some big medical device companies. And now I went to the other side to drive change on the supplier side, and we're a flexible converter. So looking forward to having more discussion on this topic. And so really, we've identified already through Matt's presentation, this isn't a trend. Matt, I loved your statistic about if healthcare does nothing until 2030, that it will be 10% of the carbon footprint or of the, greenhouse gas emissions. I thought that was a really interesting statistic that I know I'll be sharing internally at my company. And again, what I will say is there's definitely a business aspect to this as well. Matt, you alluded to the economics of it all, but companies, not just from a financial perspective, because in the past, companies were really focused on financial objectives. They're now moving more to profit and purpose. So even to retain talent, they have got to ensure that they're talking about sustainability and ensuring that, I lecture at Michigan State University. I've been doing it for 10 years. And over the past probably 5 years, not a class goes by without someone asking about what are we doing in sustainability. So the change makers are coming. A lot of the change makers are already here, but it's important for companies to retain talent and recruit talent with ensuring that sustainability is top of mind. This is just a quick snapshot of the top 20 medical device manufacturers. 75% of them have established packaging specific goals and priorities, whether it's creating specific packaging or sustainability teams within their organization, whether it's, ensuring that whether they're creating plastic and packaging reduction targets. This drumbeat is getting louder, and us as healthcare packaging suppliers are hearing it and feeling it every day. So what I want to talk a little bit about too, and this is something that I've been using internally and within industry to help people understand the business case behind sustainability, right? So there's obviously a passion that I have for sustainability, to leave this earth better than I found it. But also there are many people who want to ensure that they can keep a thriving business through this. So, or through creating sustainable practices. So what's really driving this, and what I think is going to continue to drive this, is taxation and regulation. So extended producer responsibility legislation is being introduced and passed all around the world. So in the US, for instance, our first legislation was just passed in Maine and Oregon recently. Obviously, additional details are being worked out as far as how they're going to manage that, whether healthcare will be included or not. But MDMs are going to start paying for wasteful plastic. In the EU, you're all familiar with the Packaging Waste Directive, and many countries chose to exclude healthcare waste, but the UK is a country that did not. They're including healthcare waste in the taxes for non-recyclable plastic waste. Italian has the labeling directive that I don't know about you all, but we're all still trying to figure out what that means and how to align across industry. South Korea has a mandate that ensure that, if people fail to follow the obligation, they're subject to recycling charges. And so there's definitely this business case of how and why MDMs are going to need to start focusing on sustainability and preventing plastic waste, non-recyclable plastic waste into their product development. And so, with that, I would like to say, I'm going to hand it over to Kiley here in a second. Kiley and I are really fortunate to lead an amazing group of industry professionals, and she's going to tell you more about that. And some of the things that we're doing and the industry is doing to help charge forward with sustainability in healthcare packaging. So what now, Kiley?
Thanks, Jen. So, as Matt mentioned, some of the progress being made in other markets, healthcare packaging often gets overlooked when discussing sustainability and the shift towards circularity, and that shouldn't be the case. There's fantastic opportunity in this space with high quality, high value materials. So the group that Jen and I co-lead through Kilmer Innovations in Packaging, and we're very fortunate to lead this group of passionate industry professionals who represent stakeholders along the healthcare packaging value chain. In organizations such as Kilmer and HPRC, I'm not sure if any of you have heard of them, Healthcare Plastics Recycling Council. These are a couple of examples of organizations bringing together stakeholders from across the value chain to create solutions to sustainability challenges in our space. Change doesn't happen in a vacuum, and especially in a highly regulated environment such as healthcare and healthcare packaging. So thank you, Jen. So who are the stakeholders? Well, first and foremost, we always have to remember we have to start with the end in mind, and that is the priority is always the patient and patient safety. It's paramount above all else. So progress cannot come at any risk to patient safety. Another one that, some of these may be a little bit more specific in the North American context, but sustainability focused NGOs such as Practice Green Health, an arm of Healthcare Without Harm, are influencing this value chain as well. Healthcare systems and group purchasing organizations, GPOs, have developed environmentally preferable purchasing criteria to weigh sustainability performance metrics as part of their supplier contract award process. And in the US, just to put that in the context of why that's important, in the US, GPOs control over 70% of spend in healthcare for medical and 90% of pharmaceuticals. A couple of these logos that you see here represent the largest. So Vizient, they represent over 100 billion in purchasing volume. And then another stakeholder are the major healthcare service providers. They're committing to zero waste initiatives. Large pharmacy chains are demanding sustainable packaging solutions for consumer products sold over the counter. And how they're measuring this are typically around those EPP criteria. In the Vizient case, they have, I believe it's 23 chemical and waste related attributes that pertain to packaging. So when, to go back to something Matt mentioned about some of the progress we made in those other markets, Jen, you can flip the slide here. One thing that our group has been using as kind of a, I don't say North Star, but a nice reference point is a resource that the Ellen MacArthur Foundation released about a year ago. It's the Upstream Innovation Toolkit, and it's a resource for eliminating plastic waste. And I'm not sure if any of you have heard that phrase before, upstream innovation. Just to put some color around that, when it comes to circularity and circular economy, upstream innovation is really about tracing a problem back to its root cause and addressing it there. So rather than working on how to deal with the waste, try to prevent it from being created in the first place, or find a innovate on the front end. So as you see here, our group has really been focused on upstream innovation. There's fantastic progress being made downstream. We have a small group, so we don't have all the resources at our disposal that some of these larger groups are doing fantastic work have. But where we can make an impact is upstream and really identifying what those barriers are to progress. What you see here is the upstream aspect, and material selection you'll see is top. We have, oh, there we go. Lost my screen for a moment. So there are a couple of different ways that we have approached that. The image that you see, the graphic that you see here, that represents advanced recycling. So one of those EPP criteria is integrating PCR, post-consumer recycled materials. Now, as I'm sure all of you being regulatory gurus, I'm sure you probably cringed hearing that, but there's obvious challenges with integrating PCR materials through a mechanical recycling process. But there's emerging technologies that you are probably have all heard references, either advanced recycling, chemical recycling, or molecular recycling. And those technologies are really taking plastic back to the building blocks. Those technologies for healthcare at least are not commercial at this point, but as we all know, it takes time to get there, and it's very early stage, but it takes time to get there and questions to be answered, and those questions aren't going to be answered unless we start now. And you can there we go. So lost my screen there, Jen, sorry about that. So in terms of starting with the end in mind and focusing downstream, we want to think about what is the impact that material selection has on the end of life. If the end of life is going to be mechanical recycling, the monomaterial packaging solutions is paramount. If advanced recycling is the potential, we need to identify how are those going to be collected, sorted, and what are those end markets look like. Oh, sorry about that, Jen. My screen might have frozen on me. And I will pass the time back to you.
Awesome. So thank you, Kylie. So one of the things that I wouldn't say one of the things, the main focus of our Kilmer Innovations and Packaging group is advanced recycling. We've been working together for the last 2 years, meeting bi-weekly. And the first few months, Kylie will attest to this, was challenging because we thought, what can we do in this space that isn't already, we don't want to overstep with HPRC and what they're working on. What are some things we can focus on? And advanced recycling kind of came top of mind, because what advanced recycling is, and what I really, really want the people on this call to help us understand is, and vice versa, help you understand, is advanced recycling is breaking mixed plastic waste down to the monomer level so that you can create virgin polymers. So technically, we need to ask ourselves as an industry, when does a change become a change? Because do we know which dinosaur the fossil fuel came from? We probably don't. So does it really matter what feedstock, what the plastic waste was that created the feedstock that creates these monomers? So, I would say that our industry is very risk averse. patient safety is number one importance. But I think what we're going to be challenging our industry to do is understand a little bit more about the science behind how these plastics are made in the first place. And I think we're going to have some barriers there. So when we're thinking about creating advanced recycling and why it's important, because if you think about advanced recycling, it really does create circularity within the entire value chain. I mean, you can do this process to a material as many times as possible because it's breaking down those products down to, or those plastics down to that monomer level. So what are some of the barriers? I'm sure all of you may already be thinking about some barriers that we may run into, but here are the 4 that we're going to be tasked with overcoming. The first one is that value and cost, because again, as Matt had alluded to make the economics work, you have to have demand, you have to have the amount, you have to have supply. And right now, this is a new technology in our market, and therefore the cost is much more expensive, especially when, I should say, what we're looking to do is how do we create a business case to show the taxation that you may be receiving would offset this cost if you were able to get advanced recycled materials into your supply chain. You may be able to prevent many taxes that you would be faced with. So this is something the group is still trying to understand, this concept of mass balance, which is very, very complex and hard to explain. In fact, I am not the expert at it, but this group is doing a lot of learning from the experts when it comes to mass balance, so we can create develop a very easy way to explain mass balance from what is a very complex topic. And then the second piece is regulation, right? So I talked about this for a moment and said, when does a change become a change? That is the question here, because what our teams and what our customers and me as a packaging engineer, what we typically do is we want to prove it out. We want to say, okay, well, if you're saying that material is identical, then I need to prove it. I need to do some testing. Well, but do we? That's the question here when it comes to this polymer science and plastic science is, do we really have to test? Or could you swap out virgin resin for advanced recycling resin if the science tells us that it is virgin resin? So there are a lot of questions being had, a lot of discussion being had here. We're looking at our regulatory documents, our standards like ISO 11607. There's an advanced recycling ISO standard that will be coming out. And how do we put some of these concepts and science into these standards to say, hey, a virgin resin is the same as an advanced recycled resin. And so it makes us easier to accept these types of changes, quote unquote, changes in our industry. The third piece is really around manufacturing readiness. So this is new and going to be new for many people many organizations across the value chain. ISCC Plus certification is necessary from the resin producer all the way to the MDM. And the certification is what helps define mass balance and ensure mass balance is happening, so that we can count the number of credits of advanced recycled credits so that we can actually prove circularity. And then lastly, because all of those 3 topics are very complex, I'm not the expert on all of them. Kiley and I are just really fortunate to lead a group of really smart people, is how do we educate our industry on these concepts, on these barriers, so that we can get additional collaboration and additional acceptance to make progress as quickly as possible, really, for the benefit of sustainability while ensuring patient safety. So that's kind of, what we have to present today, and what the Kilmer Group is doing, and some big barriers that we're trying to overcome. I welcome any questions that you all may have.
Excellent. Thank you, Kiley and Jen. I love the energy that you bring to the talk about packaging. You don't always get that, especially with medical devices and our regulatory group. I don't see any questions coming in specifically relating to your guys' presentation. I think everybody has to like take it in. I love the whole advanced recycling. When we first met and you were telling me about it, I was like, what? That can really happen. So yeah, that's pretty neat. I am going to move on to Anna Lindblad from Olympus, who's going to talk about a very different approach to sustainability in healthcare. And this is looking at the decontamination reprocessing for endoscopes and what Olympus is doing with that. So, we've got the design element from Matt going into packaging as well. And then Kiley and Jenn talking about packaging. And then now Anna, from the use perspective. So I'm going to turn it over to her, and we can bring in, continue to put your questions in the chat, and we'll have time at the end for a couple of questions, I believe. So yeah, and it's all yours.
Thank you. Just gonna share my screen, hopefully.
Yep. Yep, there you go, presentation mode. Very good.
Perfect. Yeah, thank you very much. Yeah, so my name is Anna Lindblad, and I am a product manager at Olympus. And you're being in the medical field, hopefully know of Olympus, but we are a medical device manufacturer, probably mainly known for a presence in flexible endoscopy, but we also offer therapeutic and surgical solutions, as well as decontamination capital equipment and products. So this presentation is going to focus around some of the sustainability initiatives and kind of projects going on in endoscopy, and more specifically around the endoscopy decontamination process. So the process of decontaminating or reprocessing reusable flexible endoscopes. We've also completed a bit of a case study in association with a new product launch that looks specifically at reducing the environmental impact of the decontamination process. So I will also be presenting some of the results from that. So Lena mentioned initially the NHS targets for the healthcare service, and I think most of us have probably seen these infographics. So this is from the NHS Net Zero report. So we've got the NHS Net Zero target split into two main categories. So the NHS Carbon Footprint and then the Carbon Footprint Plus. And then there's 4 different scopes of delivery within those different categories. And for the NHS Carbon Footprint, we have a net zero target of 2040. So this is looking at the elements of the service which the NHS can influence directly, so part of their daily operations. And when we look at scope 3 and 4, or the Carbon Footprint Plus, we're also bringing in obviously the supply chain and things that lay perhaps a bit outside of the direct control of the NHS, but which they can influence, which we have felt as a medical device manufacturer, and it's becoming obviously increasingly important for us and other manufacturers to demonstrate our dedication and progression in terms of producing and delivering more sustainable products. The medical devices and the medical equipment contribute to a very large part of the overall footprint of the healthcare service. So we can see that on the little pie chart on the right. And again, I think it just kind of correlates back to what the other presenters have been talking about, is that there is a big pressure on suppliers. You know, we need to not only look at how we develop and manufacture products in a sustainable way, but I think it's also important to look at how do we manufacture and develop products and processes that, when they are in use by the NHS, support the reduction in scope 1. So looking at things like water usage, electricity, and how can we innovate those processes, especially for diagnostic services such as endoscopy. And this can be very difficult because, as also already mentioned, we of course are subject to a lot of regulations when it comes to medical devices, but also when it comes to the reprocessing of medical devices. So this is really where I think, from a manufacturing point of view, but also from a customer, but also a regulatory point of view, we all need to come together to try and understand how we can best support the net zero targets. So I wanted to talk a little bit about current initiatives within endoscopy as a clinical discipline. So endoscopy is the third highest generator of waste in healthcare. So this is due to a number of reasons. So we have a high throughput of caseloads, which is only going to increase now with the screening backlog as a result of COVID. We also have multiple non-renewable waste streams. So looking at the consumables used in endoscopy, so endotherapy, single-use devices, PPE used, any other type of therapeutical equipment. And then finally, we have a resource-heavy decontamination process for the reusable flexible endoscopes, where they go through several reprocessing steps to ensure that they are safe for the next patient. So the Green Endoscopy Group, if you haven't heard of it, is a collaboration of international healthcare professionals, and they aim to advocate an effective lead change within endoscopy and related specialities to ensure that they can enhance the sustainability of their overall service. And a couple of examples of things that the group have been looking at. One is around looking at what's called a discard strategy, where artificial intelligence is used as a technology to be able to better identify and detect polyps, and by doing so reducing the amount of polyps that's sent for pathology testing. And by doing that, obviously you can reduce the transportation of those biopsy pots, but also the biopsy pots themselves, which are made of plastic. Another quite interesting area they've looked at, I suppose, from more of an infection prevention point of view, is looking at the use of sterile water for flushing. So when you have, for example, a colonoscopy, you often need to use water to flush to better visualize the colon. And they're looking at moving then away from purchasing sterile water that's been sterilized elsewhere, then transported, water's very heavy, and bringing that into the hospital and looking at how can they purify the water to a sufficient standard within the hospital. So using different purification systems, or even using the in-house sterilizers to kind of provide that process. And I think one thing that's become very evident from Olympus's point of view, trying to interact with these kind of working groups and trying to understand, what the NHS are doing with regards to scope 1, is that there needs to be, a very good working relationship between the NHS and suppliers, so industry effectively, because that's really what's going to be able to drive like an impactful change. And when we look at decontamination, it gets even trickier because most of the current initiatives are driven by clinicians, and their core area is not what happens to an endoscope in between patients. Obviously, they are very clinically focused. So there is a need for us as a medical device manufacturer, but also from like the decontamination society and industry to promote and support in looking at how we can kind of improve that process. Another big consideration when it comes to the, and I touched a bit on this already, when it comes to the endoscopy as a service and the kind of footprint of that service, is the single-use consumable. So like I said earlier, endoscopy has a large proportion of non-renewable waste. And one quite interesting thing, if you look back, I would say probably about 15 years, most of the endotherapy devices that are used, so the things on the picture here, for example, so you got like a biopsy, forceps, or a snare, they used to be reusable, so they used to be reprocessed effectively and then used on the next patient. But there was a big shift in this following, I would say, a push from the healthcare sector to move to single-use, so single-use sterile consumables effectively in terms of anything therapeutic used in the procedure. And that's quite interesting because now we're kind of seeing a shift back where we are getting asked for reusable rather than single use. And then of course we have the introduction of single-use endoscopes, which I don't think anyone has missed if you're in the endoscopy field. And this has drawn a lot of attention to the environmental impact of the reprocessing cycle and what is used in that process of water, chemistry, PPE, etc. And I think it's fair to say from a sustainability point of view at the moment, moving everything to single use is going to have quite a devastating effect. But there is definitely a place for single use, but it needs to be obviously for the right patient at the right time, where it's deemed necessary that, you know, a scope needs to be sterile. And I think overall, this kind of raises the question of how we manage the balance between sustainability and infection prevention. And like Kiley and Jenn mentioned earlier, obviously the key importance here is patient safety, right? How do we ensure that anything that we implement that may make the process more sustainable doesn't have a negative impact on the safety of the patient? And again, I think COVID is a good example of this, where I think sustainability or any kind of effort towards sustainability was put to the side to, I suppose, benefit the effort of reducing the spread of COVID. So looking at face masks, for example, looking at the amount of PPE used in hospitals, the amount of chemistries used to kind of disinfect surfaces, etc. But hopefully, you know, as we are kind of, I suppose, coming out of COVID, I think it's important to kind of have another look at the decontamination process for not only flexible endoscopes, but also thermostable surgical instruments, to look at what kind of quick wins we can realize in that field. So endoscope reprocessing then. So when we started looking at this, so obviously Olympus manufactures the endoscope, but we also provide decontamination solutions. So the products and the capital equipment that are used to reprocess flexible endoscopes. So I would say that there are kind of three core areas to consider here. And this is, I would say, a top level summary. I'm sure there are loads of other things as you kind of get into the details that we can investigate here. We've got water. So the decontamination process for endoscopes and surgical instruments in general is a very water hungry process. So for endoscopes, we've got 3 steps that require water. So 3 cleaning steps effectively. We then have the consumables. So we have the personal protective equipment that is almost always single use these days. So single use plastic aprons, face shields, etc. And again, I think here we're bringing in a third element to that balance. So we've obviously got infection prevention and sustainability, and then the patient safety, but also the safety of the staff that are handling contaminated medical devices. So obviously they need to be protected from any potentially hazardous contaminations. We've got cleaning brushes, so used to clean the channels, the working channels of the endoscope. Again, similar to, I would say, the endotherapy devices. In the UK, many years back, we used to have reusable cleaning brushes that would be kind of sterilized or reused on several endoscopes. But from an infection prevention point of view, we've now moved to single-use brushes. These are plastics and they are contaminated after use, so they will go as contaminated waste into the waste stream. And then looking at some of the storage methods for flexible endoscopes and the way that we transport them. And then I think single-use accessories. So one thing that has been, I would say, quite popular over the recent year is moving to single-use buttons. So that are used on the control body because they were deemed at a higher risk in terms of reprocessing or migration between different endoscopes. But again, I think anything single-use that is introduced, there obviously needs to be a balance and a risk assessment in terms of both infection prevention, patient safety, but also from now a sustainability point of view. And then the chemistry is the final thing. So we use quite aggressive chemistries when it comes to endoscopes. So they cannot be thermally disinfected because they are thermoliable. So in the UK, we use peracetic acid for the high-level disinfection, the chemical disinfection for the scopes. And these type of chemistries need to be contained in very specific type of plastic according to regulations. But what's quite interesting here is, I think, detergents, for example, are not hazardous chemicals in the same way and do not need to be contained in the same, I suppose, like thickness or quality of plastics. But what we often see is both detergents and disinfectants from the same manufacturer being packaged in the same type of container. So perhaps there are some wins that we can kind of realize there by looking at, you know, what type of plastic is actually required for, you know, what we are looking to contain. So the area that we looked at in the little case study that I will hopefully give you an overview of in a little bit is water consumption. So like I said earlier, the endoscope reprocessing cycle is very water hungry. So we've got 4 steps effectively to this process. So we've got the bedside clean that uses about half a liter of water. This is a very small proportion of the overall water consumption for an endoscope. So I would not say that that would be, I suppose, our kind of initial target area. We've then got the manual cleaning and rinsing. So this is where the endoscope is placed into a sink, you dose your detergent, and you do your manual clean, which then prepares the endoscope for the automated high-level disinfection process. And in those 2 steps, which are also the most high in terms of water consumption, we have actually got some opportunities for savings when it comes to the kind of the water consumption. And we then got an automated process. So this is using an endoscope washer disinfector. And there are also some considerations here where we've got quite a big spread in the amount of water used when it comes to, you know, what type of endoscope washer the hospital has. So there's a wide range of options on the market. So you can have a single endoscope washer that tends to use more water per endoscope, or you can have a multiple endoscope washer that tends to then keep the water consumption per endoscope down. But again, it all comes down to your operational requirement, because, you know, if you don't have a high enough throughput of devices to warrant the need for a multiple scope washer, you will end up putting 1 scope in, and you will have a higher consumption of water per endoscope. And another key thing, I think, when it comes to the automated reprocessing is the type of water that feeds these machines. And this is also applicable for sterilization and the type of washers used to surgical instruments. So in the UK, these are normally fed by ROs, so reverse osmosis water purification systems. So they are big plants that effectively purifies the water and ensures that the water quality in the cycle and the final rinse is of a predefined microbiological quality. Now, these type of systems create a very large amount of wastewater as part of that purification process. And I think that's going to be hopefully something that will be on the topic for from a decontamination point of view, in that, you know, can we look at alternative purification systems that don't dump a large amount of wastewater? But also important to say that when we look at the water consumption for a decontamination process, is that we can probably add on another 30% on top of that, because we're talking about the amount of water that is wasted in the purification process itself. So what does this look like then from a national point of view? So looking at the UK, so as we can see, the biggest area of water consumption is the manual cleaning and rinsing. So the cleaning the endoscope with the detergent and then rinsing off that detergent effectively. So that we can see here accounts for 56% of the overall water consumption. And in the UK annually, we reprocess about 2.9 million endoscopes. So that would be about 262 million liters of water used for endoscopy decontamination only. If we were to include something like, you know, sterile services, where all the thermostable instruments go, then this number would be significantly higher, because then we're talking about using thermal washer disinfectors, but also steam sterilizers, which also requires to be fed with RO or purified water. And it's estimated that the NHS uses about 40 billion liters of water a year. So this process alone would account for about 0.7% of that, which I think is quite significant, as we're talking about the reprocessing for a single type of diagnostic service, right? We're not talking about the reprocessing of all medical devices, such as those going through a sterilization process. Just a bit of an example of something that we found when we started to, I suppose, get out and about and looking at some of the differences in terms of, like, you know, what we see in decontamination units. So the process itself in the UK is quite standardized. We have a very, I would say, high standard when it comes to medical device reprocessing, which we should be very proud of. But an example here, and I think this kind of correlates to what Matt said earlier about then kind of short-term modification or quick wins. So if we look at the type of sinks used for the manual cleaning and rinsing process, a larger sink will have a substantial contribution in terms of the water usage. So the minimum sink recommendations for a GI flexible endoscope is 50 by 50. So that's in line with the Olympus IFUs. And one of the sinks that we've spotted, and seen quite a few of these, the one on the left will use 131 liters per endoscope. So every endoscope that comes through that decontamination unit takes 131 liters to fill that up twice, because we need it once for the detergents, the cleaning, and then we need to fill it again to rinse it. If we look at the sink to the left, which is 50 by 50, that would require 40 liters of water for the manual cleaning and rinsing. So very simple thing, but as we can see, 69% reduction and 1.8 million liters of water per year if we would take an example of a reprocessing unit or hospital doing 20,000 endoscopies, which is not unrealistic. I would say that's probably a medium size to a larger hospital. Yeah, so just an example of, I suppose, something that's quite simple to implement, especially if you are designing a decontamination unit or you're replacing your sinks, but it can have a big impact on the water usage. So I'm just gonna, I suppose, go through this quite quickly because I will run out of time. But we carried out a case study looking at the water consumption in endoscopy reprocessing. And this was done in conjunction with Olympus validating a new process when it comes to the manual cleaning and rinsing of flexible endoscopes. So the way that it's done at the moment is that you have your detergent, which is your cleaner effectively, and then you have your disinfectant in your endoscope washer. And in line with applicable regulations and guidance, you would verify the cleaning efficacy of your detergent separately, and then you would verify the disinfection or the efficacy of your washer disinfector with a certain chemistry separately. But what that type of process relies on is that you fully rinse off your detergent before you place your endoscope into your washer, because detergents have very poor penetrative ability. So if there's any disinfectants, if there's any residual detergents left on that device, they can have a negative impact on the high-level disinfection process. So what Olympus did when developing a new detergent is looking at the validation from a process point of view. So by confirming the compatibility of the detergent in the sink and the disinfectant in the washer, we could provide a validation that would remove or omit the need for the rinsing step in the cleaning process. So 28% of that overall water usage. So that's possible effectively by confirming that there is no adverse impact of the residual detergent on the high-level disinfection process. And yeah, this is obviously something that can be, you know, realized by other manufacturers as well. But I think it's a good example of how, you know, we can innovate not only products but processes. And this is where it's key to have that, I think, collaboration between the manufacturer of, you know, the medical device such as Olympus, who write the IFU from the process. But there is undoubtedly going to be questions from hospitals, perhaps a bit of hesitation around this, because in Decon, I would say we're quite set on the way that we do things and very worried about, you know, deviating from what the guidance say and what the regulations say in some aspect. So yeah, support from, infection prevention consultants, auditors, etc., is definitely going to be needed to ensure that hospitals feel, comfortable with kind of moving away and implementing a new process that is obviously fully validated, which is important. So this case study then, so we looked at 67 hospitals across the UK, and we looked at how much water could be saved effectively if we were to remove the manual rinsing step in the decontamination process. So on average, each hospital used 25 liters of water for the rinsing step. And the average saving then, depending on how many procedures they do, so how many times they need to clean the scopes, was 375,000 liters of water, with the maximum opportunity for an individual hospital that used 30 liters and had a very high procedure number being just over 900,000 liters of water. Just by removing this rinse step and moving away from a product to a process validation. We also looked at efficiency improvements, because rather than having to fill your sink up again and rinse your endoscope, you could take it straight from the sink into the endoscope washer, and the average time saved for decon units was 398 hours, which is quite significant, especially as pressures are growing on the reprocessing units in line with increased procedure numbers and the backlog of screening. So if we look at this from a national perspective, so if we were to remove the rinsing step from every single endoscope that is reprocessed in the UK, we could reduce the water usage by about 72 million liters a year, and we could also then obviously realize some process efficiencies by removing this rinsing step. And because we don't need a separate rinsing sink, you could also say that further down the line this would result in a reduced number of sinks required, so it would also reduce the manufacturing of the sink and the impacts of that. Yeah, so I think in summary, any, I suppose, innovation or sustainability effort within decontamination, there's always going to be a matter of finding that balance between patient and staff safety and sustainability. So looking at changes we can make that doesn't implicate the efficacy of the process. And I think this is also where it's important to consider how we can support the scope 1, so the Nhs Carbon Footprint, by optimizing not only our product, so ensuring that we manufacture and deliver products in a sustainable way, but as a medical device manufacturer, how can we create products that, when in use, results in an impact from a sustainability point of view. And small changes can lead to a large sustainability impact. So the example of the sinks, for example, just because we've done something in a certain way for a long time doesn't mean that there cannot be a change to that if we take a risk-based approach. And then I think overall it's a matter of working in collaboration with the hospitals, us as a medical device manufacturer, infection prevention consultants, but also from a regulatory and quality point of view. I would be very surprised if you don't get questions as like an auditor or from a regulatory perspective with regards to proposed changes in processes, or can we do this, can we do that, how would that impact our certification or the quality of like a certain process. So yeah, that is the end of my little presentation. Thank you very much.
Thank you, Anna. That was there's so much information and so many different opportunities for us to look at sustainability. We are almost out of time. There is a question here for you regarding how has Olympus responded to the challenge and opportunity presented by third-party remanufacturing businesses such as Vanguard. And I think Zach might be here to help answer these as well with you.
Yeah, so I've got Zach with me here, who is our sustainability lead for the UK for Olympus. I am not aware of this specific opportunity with Vanguard. I don't know if you are, Zach?
Not so specific in that element, but the opportunity is there. Somebody has to take a step, as Matt alluded to, with being the first one is the most challenging one. Third-party remanufacturing, it's an opportunity there. I'm not sure how Olympus globally has approached it, because obviously in the UK, my manufacturing sites are predominantly workstation flushing, but that kind of thing. But it's certainly something we can answer going forward.
I think the whole concept of, remanufacturing, recycling, reusing things is really, it gets into kind of Neil's comment here about, because there is a lot of talk about patient safety and what is the risk, and we have the benefit risk ratio, and by using recycling or by minimizing, changing a packaging and using different materials, what is really that impact to risk? I think that could be an entirely separate session for us to talk about the risk aspects of sustainability. So that's Neil, I'm going to make note of this and possibly add that to a later conversation, because it really is patient safety. Are we ever going to eliminate risk, or eliminate the risk of patients, reducing patient infection 100%? Not likely. And what's the cost of that versus reducing some of the waste burden? So lots of great information. We don't have time for a lot of additional questions here because we are at the time, but wow, there's just so much for us to consider when it comes to sustainability. So please, think about what you can do within your corporations to incorporate some of these principles, and also consider engaging in conversations on our different UK RAPS UK pages, such as on LinkedIn or Regex, so that we can really start to embrace some of these changes and learn from each other as well. We're not in this alone, we're all in it together. So let's learn from each other. And again, I want to thank all of our speakers, Matt, Anna, Kiley, Jen. Thank you, Zach, for contributing at the end part of this, but really appreciate everything. If you have any questions, please pop them into, you can email them to us or put them into the, like I said, LinkedIn, and we will respond to those. We will be making the recording as well as the presentations available to you after the presentation. So look for them later this week. All right, thank you all. Have a good night.
Thank you, Lena.
Bye.